As the next stage of our discussion of curve sketching in the geometry of functions, we're going to talk about indeterminate limits. For example, what happens to h of x, which is e to the x minus 1 over x, as x goes to 0? Notice that we can write h of x as a ratio of two functions, f of x over g of x, where f of x is e to the x minus 1 and g of x is just x. And notice that f of 0 is 1 minus 1, which is 0, and g of 0 is also 0. And so that means if we plugged in, h would be going to 0 over 0. And 0 over 0 is something that mathematicians call indeterminate, which is to say it could have a value, just we have no way of deciding right at that moment what the value is. So 0 over 0 is an indeterminate limit. Infinity over infinity is another example of indeterminate limit. And fortunately, we have a rule to take care of what happens when we're trying to evaluate an indeterminate limit. And so, if we have an f that goes to 0 and a g that goes to 0, or we have an f that goes to infinity and a g that goes to infinity, either way, the limit as x approaches c of f of x over g of x, which would be the indeterminate limit, this limit we can evaluate by taking the same limit of the derivatives. So for example, here, f prime of x is just e to the x, and g prime of x is just 1. So the limit as x goes to 0 of e to the x over x, this is going to be equal to the limit as x goes to 0 of the derivative of the numerator, which is e to the x, over the derivative of the denominator, which is 1. Well, here we can just plug in x equals 0, we get 1 over 1, which is 1. And indeed, that is the value of the limit. And if you graph h of x, you will find that what it has at x equals 0 is a hole. It has a hole with the coordinate 0, 1. This particular rule is known as L'Hopital's rule, and we'll be talking about many applications of this in the next couple of videos.